case anyone else doesn't see it. So here in bold, it says quiz. This was last week. And then here in bold says this, and then there's the date right next to it. So you can plan ahead for these things. They're not surprises. Okay. Now, I'm going to move to the review notes. I'm not sure how long this is going to take. So I'm going to do this with you guys, then give you time to work on your review assignment while I stamp as much as I can. But I'm not sure how long this will take. So solve each equation by taking square roots. Okay, so I need to get the x alone first. Plus 8. Plus 8. Divide by 25. Okay, this one is extremely lucky. Can anyone tell why it's a lucky one? Why this is an easy one? Yeah, they're both perfect squares. Okay, so the moral of the story in this problem is get the x squared alone first, then square root. And don't forget your plus or minus. Do you guys all understand how I got 3/5 from the square root of 9 25ths? Okay. Number 2, solve each equation by completing the square. There's only one type of completing the square on this page. There's 3 different types though. We did them yesterday. This is the first one. The other one was vertex form, and then the last one was a circle. On your review assignment, there is a solve and a circle. So just so you know, when I say completing the square, it's not just this. It could be this. It could be a vertex form, or it could be a circle. Any of those. Anyway, step 1, move the constant over. Step 2, complete the square. You can do that in any way that you like. I'm going to do it with the box. When I make my box, I put p squared in the first box, and then I split negative 18p into 2 equal pieces for the other 2 boxes. Then I factor here. And that makes positive 81 tiles to complete the square. Do you all see where the positive 81 came from? Are you sure? Okay, now I'm going to add 81 to both sides. It's weird because number 2 on the review assignment, the radius is the square root of 111. How often are we going to get 111? It's weird. Okay, anyway, next step is factor. So p minus 9 squared equals 111. Everybody see where I got the p minus 9 squared from? Super important. Okay, now solve by square roots. So now we do this. Don't forget the plus or minus. And put the 9 in the front. I assume that 111 is not simplifiable. Is 111 prime? Anybody know? If I had my phone, I could tell you, but I don't have it, so can't tell you. But I'm thinking it's prime. Okay, pausing here. Any questions about number 1 or 2 before we move on? We good? You sure? Okay. Number 3. This is vertex and a point. So I'm going to go H, K, X, Y. I want to talk about this little bit right here. This is telling you that your parabola is up or down and not sleeping. So keep your eye out, because now after you've learned the sleeping parabola, if this say opens right or left, you're going to have to use the sleeping parabola formula, not the regular parabola formula. So this is telling you to use y equals. And if it says opens left or right, you'd have to use x equals. So that's why this bit is here. This isn't here for you to circle an answer at the end. This is telling you you have a regular up or down parabola. Okay, anyway, which is y equals a x minus h squared plus k. (134) equals a -5 plus 8 squared minus 10. Okay, I really want to focus on this plus 8. Are you all completely 100% understanding of why I put plus 8? Okay, if you don't like that, write minus -8. It's no big deal. Okay, now rescue the constant before we do something silly. Okay, any questions about my final answer? Well, like on this quiz that I just passed back that this was on, I think the class average was a 94. So pretty sure almost everybody can do this to perfection. Okay. What? Anything about number 3 before I move on? Determine if each function is even, odd, or neither, both algebraically and graphically. Then determine the end behavior. Okay, for this, I'm going to just reference the notes real quick. You guys do not need to do this. You don't have to get your stuff out. Just we're just going to look at mine real quick. But I'm going to point out probably what's note card worthy. And this I would definitely put on a note on your note card, this little bit of the notes here. Okay, so I'm going to look at the graph first. That's the easiest part. And I'm going to say, okay, look at this graph. Does it have reflection symmetry on the y-axis? This graph here. If I fold on the y-axis, would it match up? Yes. Okay, so this graph is even. I just determined that it's even and I did it graphically. So that's half of that particular problem. It says, determine if the function is even, odd, or neither, both algebraically and graphically. I just did it graphically, just by looking at the graph. Now I'm going to do it algebraically. Algebraically means that you set yourself up a little baby table of the one that we did in number 70. So here's an example in our notes. We did the original f of negative x, -1 times f of x. If it's even, these first two should match. So this is a way you can make sure that your algebra jives with your graph. Okay, under the f of x, you just write the original, x to the fourth minus 3x squared minus 4. And f of negative x, I'm going to take this x and this x, and I'm going to replace them with negative x in parentheses. So I have negative x to the fourth minus 3 negative x squared minus 4. Okay, so this is a negative times a negative times a negative times a negative, which is a positive. This is a negative times a negative times a negative, which is a negative. And those two match. Is that what we're expecting? Yes. Okay, now you can technically stop because you know it's even, but I'm just going to do the whole thing because, you know. I'm just going to distribute the negative here. Okay, now do you see the second part of the directions on this problem? So determine if each function is even, odd, or neither, both algebraically and graphically. There's my graphically. There's my algebraically. Then determine the end behavior. Okay, so what I'm going to do is I'm going to look at the arrows. And I'm going to say, okay, this arrow is going up. This arrow is going up. This setup is the same for every problem. So if you guys remember on our blue pages, this was printed on there every time. All we had to do was figure out what the left arrow was doing and what the right arrow was doing. On the test, I believe this is fill in the blank. So I think this part is already there for you. You just need to know that this one is the left arrow and this one is the right arrow. If I were you, I might just write this little bit on my note card anyway, just to make sure. Anyway, my left arrow looks like it's going up and my right arrow looks like it's going up. Okay, any questions about number 4? Anything you want to ask or talk about from that problem? Okay, so let's repeat the process over here. Number 5. Does this have reflection symmetry on the y-axis? If I fold it here, does it match up? No. Does it have 180-degree rotation symmetry about the origin? No. So that means it's neither. Do you guys know what I mean about 180-degree rotation symmetry about the origin? It has to go through the origin. This one does not. Okay. F of x, f of negative x, -1 times f of x. So we're expecting to get no matches here. Here's your original x cubed minus 2x squared plus 2. Does anybody know what part of this makes it neither? Anybody want to take a guess? What part of this thing makes it neither instead of odd? So the cubed makes it possibly odd because that's an odd number cube. It's the +2 actually. The shift up 2 moves it off the origin. Fun fact for the day. Okay, negative x cubed minus 2 negative x squared plus 2. Negative times a negative times a negative is a negative. Thank you, sir. This one is a negative times a negative times a negative, which is a negative. Okay, just distribute the negative here. Negative x cubed plus 2x squared minus 2. No matches, so neither. Yep. This is separate, completely separate question. It's just that the graphs were here, so we threw the extra directions on to make you not have to graph something else. This was for efficiency's sake. Again, this bit of end behavior is always the same every question. Only thing you have to do is figure out what to put here. It looks like my left arrow is going down and my right arrow is going up. So my left arrow is going down and my right arrow is going up. Okay, flip when you're ready. Okay. All right. Identify the vertical asymptote, horizontal asymptote, domain, and range, and sketch the graph. This is a rational function. So vertical asymptote x equals 2. Do you guys see where I got the 2 from? Do you see where I got the positive 2 from? You sure? This is the worst. Horizontal asymptote at y equals -1. Do you all see where the -1 came from? The domain is all reals except x can't be 2. The range is all reals except y can't be -1. Okay, now we're going to ignore the 4 because we're just going to sketch this in. But where should I sketch it if my fraction is negative? Yep, top left, bottom right, beautiful. Great job. Don't worry about exact coordinates. I don't care about that. I just care that you look at the negative and put it, the hyperbola, in the generally right spot. Okay, number 7, graph each equation, identify A, H, and K, and describe the transformation. This is an absolute value graph. Absolute value graphs are V's. A is -1/2, and that is vertically compressed by a factor of 1/2, and also reflected over the x-axis. The vertically compressed by a factor of 1/2 addresses the 1/2 part, and the reflected over x-axis addresses the negative part. H is +4. Which is a shift right 4. And K is -1, which is a shift down 1. Okay. How do you graph this thing? Start with the vertex. So shift right 4, shift down 1. So right 4, down 1 is here. That's your vertex. And it's telling you that it's going downward with a vertical compression of 1/2. So that means you're going to go down 1 over 2 and down 1 back 2. That was 3. And then down 1 over 2, down 1 back 2, down 1 back 2. So it's basically like a slope of positive 1/2 and a slope of negative 1/2. All right, 2 more. Number 8 is the only one where I'm going to use my calculator. I probably don't need it. I can try not to use it, but actually, I'm definitely going to use it for number 9. I could see the decimals there, but for number 8, I just want to get the square roots off the table. I don't need it for any of this business, but for this with the square roots, probably going to use the calculator. Mhm. That happy moment. Do you want to know what you don't get on the test though? Yeah. So you're gonna have to figure out what you want off of there. If I were gonna take the test, I would write the parent equation, a little baby sketch of what it looks like, and the general equation for each. I would take the domain and range just off of my understanding of domain and range, and end behavior off of my understanding of end behavior, but I would not copy all of those down because you can look at any graph and tell what the arrows are doing. So I wouldn't really waste space on that. I just write like this, this, and then you can put the locator point, but I feel like they're almost all HK, but I mean, that's up to you. And then I would just make a little baby sketch of like what the parent graph looks like so I can match it up to whatever it might be. Anyway, okay, so question for you guys is, what is the first number that's going to work in the domain here? And if you don't know the answer, it's kind of okay because you have a graphing calculator. -5, yeah, okay, so my table is going to start at -5, -4. I can tell from just looking at the picture here, or from the problem. 2 square root x plus 5 minus 4 table. Look at how much of the geniuses we are. All right, I'm just going to go to -1, 0 here. Switch sides so I can. -5, -4, -4, -2, -3, -1.2, -2, -0.5, -1, 0. And then I'm going to look at the picture so I can. Okay, domain and range. I like them on this type of graph because you can get it from the table and from the graph. I'm just going to do it on the graph like we did in the first chapter. So here's the domain. X is greater than or equal to -5. You can verify that on the graph. You can verify that on the table. Range. Y is greater than or equal to -4. You verify that on the graph, verify that on the table. The last problem. Does my table make sense? So my rules are I have to have spots for the 2 points they gave me, and I have to have a spot for 0. Luckily, it's between those, so I have it anyway. Any questions about my table setup? How many B's does it take to get from 20 to 0.3125? 3. Remember what I said? It's okay to round on your paper. Don't round in the calculator. It's okay to round on your paper if you're too lazy to write the whole thing out, but don't round in here. All of the roots are located in the math menu. I want the cube root, so I'm going to go to number 4. And then I'm going to lazy scroll up to that so it's highlighted and hit enter so it pastes it in. And then go one spot down the table to get A. A is whatever is next to the 0. Y equals A B to the X. Okay, pause real quickly. I'll come back to this in a second and leave it up there. But I want to talk about this. Let me increase the font size. Okay. Make sure you guys know what all these things are. That's this Friday. We use the front and back of the 3x5 jump card and a calculator. The note card must be handwritten and collected for test. Two multiple choice questions at the beginning, identifying a question as even, odd, or neither, and completing the square. You know what those things are. Okay. The two in the middle, creating a box plot for the list of data. You're going to have to figure out how to do that on the graphic calculator if you don't know how to do it by hand. The notes are in problems 101 and 102 from chapter 1. You're going to have to go back and research that. There's one of those on your review assignment. It'll be really good to help you remind yourself how to do that. Identify the locator point in a transformed graph, any from the parent graph summary organizer, describing the transformations and writing the equation. Okay, so it's going to be like a picture. We're going to have to identify, like, draw in the locator point. So it's either the vertex, inflection point, whatever. You're going to have to say, okay, that's H and K, plug those into the equation, and then say shift left 3, shift down 5, whatever. Graphing a transformed graph, any from the parent graph summary organizer, identifying the domain, range, and end behavior. They're going to give you an equation, you graph it, identify the domain, the range, and the end behavior. And writing a vertex graphing form equation of a parabola given the vertex and a point. That's the, what was that, number 3 on your notes? Where you have the vertex and a point, plug in x, y, h, k, solve for a, write the equation. Any questions about the top? You guys should be working on your review assignment. That's due tomorrow. I'm gonna come stamp as much as possible. If I don't get to you, it's okay. I'm just gonna pick up that tomorrow because we have the team test.